Okay, the last examples we're going to look at today are if the if the variable is within the argument of the logarithm. If that's the case, then you have to change it to exponential form in order to get that variable out of the logarithm and be able to then work with it. So for this first example here, our x's are all within this expression, this log base 3 of all of that x stuff. So in order to change it to get to the x's so we could solve for it, we have to change this to its exponential form. So we'd say 3 to the power 2 is equal to the argument of that logarithm. So now I need to solve this equation. On the left, 3 squared is 9. On the right, I would need to distribute. So that would give me 2x squared minus 3x. And I've ended up with a quadratic equation here. So in order to solve that, my strategy would be to create a 0 on one side and then factor. And if it won't factor, then I'll try some other things instead. So to create that 0, I'm going to subtract 9 from both sides. So give me 2x squared minus 3x minus 9. Then I would factor if possible. This one will factor. My outside product there would be a negative 18. And my pen is lagging now, which always makes the videos more interesting there. The factors of negative 18 that would add to make a negative 3 would be a negative 6 and a positive 3. So I'm going to put a minus 3 on the outside here. So my outside product is negative 6, and then a plus 3 on the inside. So the inside product would be a positive 3. Then set each of those factors equal to 0 and solve, and I would get negative 3 halves and 3. Now with this one, since we did have x's inside of our logarithmic expression, we do need to make sure that they don't violate the domain of that logarithm. What's inside the logarithm here has to be positive. Has to be non-negative, I should say. No, I take that back. Has to be positive. Can't be 0, can't be negative. So if I take each of these numbers and I plug them in, negative 3 halves, then inside here that would give me negative 3 halves, and then 2 times negative 3 halves minus 3. So inside there I would have a negative 3 halves, and then negative 3 minus 3. So ultimately that would be a negative times a negative, which is positive. So negative 3 halves is a good answer. When I put in 3, that one I can do in my head. 3 times 6 minus 3, that's a positive times a positive, which is still positive. So this one actually has 2 good answers to it. I've got a second example here to look at. So for this other one, again, the x is within the argument of the logarithm. So in order to solve it, I'm going to have to change this to its exponential form. So I would say 2 to the power negative 1 is equal to 3x plus 2. Now 2 to the negative 1, negative 1 power means take the reciprocal. So that would give me a 1/2 over there. And then to solve this as easily as possible, I'm actually going to get rid of the fraction by multiplying both sides of this equation by the denominator. So that would give me 1 equals 6x plus 4. And then to solve, I could subtract 4 from both sides, which gives me negative 3. And then divide both sides by 6, which would be a negative 1/2. Now, once again, before I can claim that this is the answer to this problem, I need to check to see if it violates the domain of this logarithm. So if I put a negative 1/2 in place of x, and it makes the argument, the part that's in parentheses there, 0 or less than 0, something other than a positive number, then it's not really an answer. So 3 times the negative 1/2 is negative 3 halves. Plus 2 would be positive. So this one is okay. So negative 1/2 is our answer. Now you try the next problem on the